Hey everybody, welcome back. I hope everyone that celebrated had a happy and safe holiday. So, coming back, we're going to start a new segment on a topic that is close to my heart: operational security, OPSEC. This is going to be a long series that covers all things related to OPSEC. And so I think the first exercise to kind of get familiar with all this stuff is to harden your own laptop, harden your own box, right? And you can learn a lot by doing that, going through and really tightening your system up security-wise. And one of the first things you do is encrypt your hard drive, right? So that's what we're going to talk about today. We're going to talk about encryption in Linux, how it works, and we're also, at the end, we're going to go through and we're actually going to create an encrypted Linux container that you can store things in that will be impervious to malware and prying eyes. So some pretty cool stuff. So yeah, so we're going to go through some theory first. I want to explain to you guys how all this works, and then yeah, we'll make something. We'll make a container to store stuff in. Okay, so let's get started. So full disk encryption, LUKS. So Linux typically uses LUKS, Linux Unified Key Setup. Whenever you choose full disk encryption during install, it creates an encrypted block device in the kernel's dencrypt layer, and everything's encrypted except the boot partition. Right? If you don't know what a boot partition is, it's basically a little blob, a little segment of your drive that contains everything that your system needs to know to kind of get you up and going, to get you interacting with the system. Okay, and I'll talk about it a little bit later. And yeah, and so everything on the disk is encrypted except this boot partition. And then when you type in your passphrase at boot, the system derives a key, opens the encrypted container, and mounts it. So when you have your passphrases, that's not being used to decrypt your drive. That's being used to decrypt a segment of your drive that contains the master key that does the decryption. Okay, and we'll get more into that. But important to know. Okay, so LUKS encrypts at the block device level, which I'll talk about shortly. Once unlocked, the system acts normally, and then the master key never touches disk. Only the encrypted key slots do. Talk about the boot partition here a little bit, what it does, the stuff that it includes. And yeah, so block device level. So what does that mean? Okay, so when Linux talks about block level anything, it's really talking about how the disk is seen by the kernel. Okay, and don't think about a drive having a bunch of files on it. Think about a drive having a bunch of these blocks on it. Okay, so when LUKS encrypts at the block device level, it encrypts these raw blocks, not the files. It's literally encrypting the thing that the files are setting in, right? The file system sits inside the encrypted container, right? And then obviously the whole point here is if anyone looks at the disk without unlocking it, they just see noise. I often say file encryption is like going into a library and locking every book, and block device encryption is like locking the entire library in a black box where you can't see anything until you unlock it. Okay, now the encryption keys. This is what I talked about earlier about how your passphrase is not decrypting. It's not decrypting your drive, right? Instead, the disk is encrypted with a master key, which is a big, long, symmetric key. Now, your passphrase is only used to decrypt a small block that contains that key, right? And that is stored, and so that blob is stored in what is called a key slot. Guys, just think of key slots as passphrases. We'll get into it a little bit more, but that's basically what key slots is. They're passphrases that you use to get keys, right? And unencrypt the system and decrypt the system, right? You enter your passphrase, LUKS uses it to decrypt the key slot. If successful, it retrieves the master key, and then the master key is used to, decrypt the entire disk. Now, as I said, you can think about these things as passphrases. Okay, LUKS supports up to 8 passphrases, and this provides a lot of flexibility, right? This allows you to add or remove passphrases without re-encrypting the entire drive, which is great because that way, if you feel like a passphrase has become compromised, you don't have to you don't have to format your entire drive and re-encrypt it, right? Which is great. You can retire old passwords, rotate credentials. You can even assign different keys to different users if you're using a box that has multiple users on it. And then a big one for me that I use a lot is creating burner passwords. And this allows you to remove them, right? So this allows you to kind of create temporary passphrases that you can, later get rid of. Right, so let's take a look at this, right? Like, so what does this look like, okay? So, this was the name of the drive on the other computer I did this lesson on. So that's probably not going to be the name of this drive. So if we do, you can get all this information by using ls block here, right? With the F parameter. Now you'll see here I have SDA5 crypto 2, right? So this basically proves, okay, well, your drive's encrypted, right? This is kind of how you can prove your drive is encrypted. You see the crypto 2 here. Now, let's take a look, right? So sudo crypt setup lux dump, and then we can do dev SDA5. Now, what is this? What do we see here? Okay, so let's go up. Now, we can see here in the data segment, right? So we're using, the system is using AES XTS Plain 64, which pretty industry standard. And this means that we are encrypting data per 512 byte sector. All right, that's what that means. Now here we see that in our key slot, I have one key slot, right, which is correct. It's a 512-bit key because AES XTS uses two keys, right? It has a 256-bit data key and a 256-bit tweet key, which equals 512. Very, very strong. And then it's using Argon 2ID for your password-based key derivation function. And Argon 2ID, it's pretty badass. It's the best KDF we have especially against GPUs. It makes brute forcing very expensive across all parameters. Time, memory, parallelism, across the board. Makes it tough. So it's a good one. Yeah, and so that just kind of talks about what we talked about here. Now, let's get into it, okay? So this is where we're talking about the optional extra layers. We're going to create our encrypted container, all right? So once you have full encryption, you can layer in more, right? And so the way that I do it, guys, is so on my main machine, every, if it's every job or lick or whatever you want to call it, every task that I'm doing that has multiple components, I create a vault for it, right? So this is really good because if you have different projects or different things you're doing that have multiple, files or whatever, you can store all of this stuff together in these encrypted vaults, right? And so this way, if so basically, if you were able to get past the first layer of encryption on my hard drive, you're going to get into my OS, and you are just going to see outside of the main Linux files, you're going to see a bunch of encrypted vaults, each with different passphrases, right? That's where projects, data, information, all is stored, right? So you layer it up, right? It's about layering it up. And so, right? So, and like I say here, right? Each vault contains only what you need for that context, right? And a breach of one vault won't compromise the other, okay? So we're going to use Lux format here to create our container. I'm going to walk through the commands, and then we're going to go through and actually do it. Okay, so the first step here is, to create your file, and we'll be using DD to create a 512 megabyte file, which we'll be using Lux format on to turn it in to a container. Okay, so we take a normal file, turn it into an encrypted block device, and then we format it, and then we prepare it so it can later be unlocked and mounted like a drive. All right. Now the cool thing here is these are just files, right? They're treated like files. You can put them on USB drives, your cloud storage, you know, on your home directory. The file is just, the vault is just my classic misspelling here. The vault is just a file, right? It's easy to hide, move, or delete. All we've done so far is create the container. We haven't encrypted it yet, right? So the second command unlocks the encrypted container and makes it available as a virtual device under mapper, right? So this is our vault, and then this will be our virtual device under mapper, okay? Now, after this, we can format it, mount it, store files in it, okay? So the OPSEC takeaway here is that you can open the vault when you need it, close it when you don't, and leave no readable trace on disk, okay? So the first thing we got to do is format it and create a file system so that we can write to it, right? And then we're going to mount it, and then we're going to close it. And then I'm going to show you guys, okay, so after you go through all the steps, you write a file to it, close it down, open it back up, do some more work, close it down again, right? So we're going to show that. Okay, so why do this, right? So the idea here is compartmentalization, like I spoke to before about how I have everything broken out into these vaults, okay? This is a core tenet of OPSEC, right? So nothing should have access to everything. A compromise in one area should not expose the rest. Sensitive materials live in their own crypt volume, and external drives are treated as hot and encrypted by default, and if seized, nothing is revealed, okay? So let's do it. We're going to create an encrypted container, unlock and mount it like a drive, use it, close it, and then verify that nothing leaks, okay? So let's do that. First thing we're going to do is take this, and what this dd command is going to do, this is going to create us a 512 megabyte blank file of just raw block of zeros, okay? So now, then what we do is we're going to turn that into a LUKS encrypted container using this command, okay? And then you have to use capital letters or it will drop, or it will not complete the operation. Enter a passphrase for it. It's going to take a minute because it's doing its thing, right? There it goes. All right, so now let's open it up, okay? And this will give us our device under mapper. Right now, if we look under mapper, we see OPSEC is there, okay? Now, okay, so that is our decrypted view of the container. Okay, now we got to format it with a file system so that we can write stuff to it, okay? We're going to use xt4. Mount, all that's done. Okay, now we're going to mount it. We're going to mount it to our home directory under the secure directory, okay? Now we can do the mount. Okay, now, I think I'm actually already here. Yep, and there we are, secure, right? And all we have there now, so that's it, right? We got the lost and found, that's it, okay? Now, secure works like any normal directory. Anything you put in here is encrypted on disk, and anything outside is not, right? So let's put something in here. So let's do, we'll just call it notes.txt. Just, I don't have Vim installed on here. So we'll just do top secret OPSEC notes. Right. There we go. All right. So we know it's readable, right? We got it out of there. Okay, now let's see the encrypted version. Okay, so if we do right, it's just noise, right? We don't see that anywhere. It's all just noise. Okay, now now let's That's pretty much it, guys. You can now we're at the stage where you can write whatever you want to this thing, right? So now let's close it down, and then let's open it back up, right? So let's unmount it. And then we will close it. Okay, now we are just left, we are still left with our vault. Okay, and we can still, I haven't installed strings on this machine, so we can just do cat, right? And we're still getting garbage. And now, right now, this is your state. This is where, when you were done working, doing your stuff, these are what you would do, right? You would unmount it and you would close it. And the only thing that's left that malware or a person can see is this. Okay, now let's reopen it. Okay. So this is how, when you want to go back in and add more stuff, right? So you can do this. Oop. Oop. I want to do one command at a time here, right? Right now, right, right, OPSEC, there it is. Now we will mount it. All right. There's our notes. And we can see them. Right, and now we can go back, and now we can go in here. Yep. Right, we've added our stuff. Okay, now we just will unmount. Oh. Duh. You can't be in the directory. All right, and then we're going to close it. All right, so we can see it's gone. The only thing we are left with is our encrypted vault. And if we were to it's just garbage, right? Cool. All right, guys, that's all for this one. I hope you found this interesting and useful. You should, because this is a great way to protect yourself and your files and all that. And so, yeah, and so we're going to continue on. The next, I'm going to do another video this week in this series where we're going to go through actually hardening up your laptop. Wanted to show you guys how encryption works, how you can safely store your data, and next in the next one we're going to go through and start actually hardening up your laptop. All right, guys, I appreciate you. Be good to each other, ask respectable questions, get respectable answers, and I'll see you in the next one.